Hi, I'm Philip, and in this video I will look at the accuracy of the Einscan Rigil, especially in laser mode. Now let's first start with the scan setup. I placed the micrometer on my turntable, and around the micrometer I used marker geometries. You can see here in the picture. So these are just used to allow scanning at more shallow angles, so I can properly capture these faces of the anvil and spindle on the micrometer I use for distance measurement. And while scanning, I didn't rotate the turntable just to prevent any wobble that may get induced into the micrometer, because as you can see on the micrometer itself, there are no markers on the turntable and the geometries. And if I would too fast rotate the turntable, the micrometer could move independently or be a bit behind. If you are interested in the marker geometries, I also linked them in the video. On the micrometer itself, I did use scan spray. The micrometer was first calibrated to 125.00 millimeters plus minus 0.01 millimeters with a calibration rod. That's for the micrometer. And the problem now is that the anvil and spindle are polished to a mirror finish. So basically we have some sort of carbide inside, I would say, for the faces that are highly polished. So scan spray needs to be used on both. For this I use Einstar Blue. This is my favorite scan spray next to the Revopoint scan spray. And the thickness of the scan spray is per manufacturer spec 8 to 50 micrometers. So since I use thin coat, I use 8 micrometers for calculation. So we have 2 times 8 micrometers. So our new nominal is 124.984 millimeters. Now to the scan settings. You now see here, laser mode and IR mode. I focus on laser mode, and I will shortly tell you why. So in laser mode, I set the target point distance to 0.2 millimeters, and I simply scan until the data quality is reached, especially of course on the faces that I want to measure on, because these are the relevant parts of the micrometer. And I then fuse and mesh at default settings. So in the extra hubs or extra Rigil software, it's a bit different from other scanners, because basically you only set the target point distance in the beginning, and then for the point cloud generation and meshing, you aren't asked again what resolution you want. Especially in the meshing, you can more have multiple factors you can influence the meshing, like the target triangle count or how much I want to simplify the data. So I would say it's a bit more of an intuitive workflow, and you're simply already prepared with the preset recommended parameters. And I did 6 repetitions for the test. For the IR scan, I did not test it because the micrometer, I would say, or from my experience, the micrometer is a bit small for proper testing, especially the faces of the anvil spindle. I would say they are maybe 8 millimeters in diameter, so this is a bit small for micrometer. For the IR scanning, the more suitable size is for large parts over 1 meter. So for myself, it's mainly I use IR scans for larger parts from maybe 5 to 10 meters. So the Rigil still works at 10 meters. So I just scanned a staircase yesterday with a total length of, I think it was 8 meters, and it worked beautifully, especially in feature tracking. So this was quite impressive. And for, I would say, the smaller IR mode or smaller parts I would scan in IR mode, I mainly use the markerless laser mode as a IR replacement. So because this is the same functionality. I did also not test markerless laser mode, because for markerless laser mode you need proper geometry to track, and the micrometer simply doesn't provide enough geometry. Also my black turntable, so I don't want to mix my mythology up too much. Maybe I will at some point add I would say special category for markerless laser scanning, depending on when Creality will add the markerless scanning features to the 7P1. So then we have final comparison, but for this I will have to get a bit more creative with my scanning setup. Now to the scan results. here are like the 6 final measures that were output from the scanning software. And you can see they are like roughly aligned, so they're not completely mixed up, but yeah, so the surface quality, especially around these screws, is actually quite fine. And for the measurement process, I simply import the STL file, or in my case, it's most likely a PLY file into Quick Surface. And then I extract planes on the anvil and spindle as primitives. So in Quick Surface, you have the extract primitive button, where you can just then use like some sort of magic wand to automatically select points like here on this face. And then it will try to fit a proper plane as closely as possible. For the second plane on each micrometer, I constrained them to be parallel, so proper distance measurement is possible, which I also do in Quick Surface. Now to the stated accuracy. So the volumetric accuracy here is for the laser HD mode, 0.04 millimeters plus 0.06 millimeters per meter. So for a 125 millimeter micrometer, that's 0.0475 millimeters. And now to the scan data. So here we have like the 6 measured iterations. The mean value of all 6 iterations is 124.971 millimeters with a delta mean, so a difference between the mean and nominal of 0.01 millimeters, so 100 of a millimeter. And the spec is at 0.0475 millimeters per spec sheet. So we are well within the specs. And now let's look at the comparison of this result to other scanners. Now here we have the comparison chart. In this dark blue color, we have the nominal as a straight line of 124.984 millimeters. And in this nearly black color, we have the Rigil in marker track laser mode with a delta mean of 0.01 millimeters. So yeah, that's very good. And if you just are more interested in like the other results, just maybe pause here and have a look at the other comparisons. What I quite like with the Rigil is the repeatability across these like 6 iterations. So that's very nice. And I hope you enjoyed, and stay tuned for the next testing and my next projects.